Hello students, today's video is called Kinematics Word Problems. The learning objective is acceleration point 3. I can use graphical and mathematical acceleration representations to solve quantitative problems. So the word quantitative here should tell you that we're going to be dealing with numbers and math, and these over here are the kinematics equations. Now you may be wondering what all that gibberish means, so let's go over some definitions. So all these letters are known as variables, and the first one, delta x, stands for change in position. The Greek letter delta means change and x means position. Another way to say that is the displacement, and the unit of measurement is meters. Next up, VI stands for velocity initial, or the initial velocity of an object, and that's measured in meters per second. Likewise, VF stands for final velocity when the object has reached its endpoint, also measured in meters per second. The variable A stands for acceleration, and that is measured in meters per second squared, or another way to say that is meters per second per second. And last but not least, the variable T stands for time, and that's measured in seconds. Now, two things I want to note. One is that the first four variables are all vector quantities, which means that they have a magnitude and a direction. For example, displacement is basically the same thing as distance, but along the path from A to B, it also has a direction. Acceleration can be a little bit misleading because we tend to think of an object that's accelerating as something that's going faster and faster. But in fact, acceleration refers to any change in velocity. So depending on the direction of the motion of the object and the direction of the acceleration, that object might be speeding up or slowing down. And the last point I want to make before we go into some examples is that the word problem might not give you these numbers in the same units. So it's possible that you might have to convert feet to meters or minutes to seconds or something like that. Alright, this is the Kinematics Word Problems worksheet, and I'm going to go over questions 1, and because I'm trying to keep this video short, I'm going to do problem 6 as well, but in a different video. Alright, the first thing you want to do is read the word problem really carefully. So I usually read it at least 3 times, and at least until I have like a mental picture of what the story is trying to tell me. So you want to have an annotation tool, so I'm going to get my little red pen. A car is stopped, I'm going to highlight stopped, at a red light. When the light turns green, the driver accelerates, highlight accelerates, the car at a constant rate of 5 meters per second squared for 7 seconds. What is the car's final velocity, and what is the car's total displacement? Feel free to pause the video to reread it a couple more times. The next thing I want to do is start assigning numbers to my variables. So here I see plus 5 meters per second squared. Right off the bat, I see that meters per second squared is the units for acceleration, and it also says that the driver accelerates the car at a constant rate of 5 meters per second squared. So I'm going to put my 5 right there. Next, 7 seconds. I know that seconds is time, so I'm going to write a 7 here. All right, and then the questions are asking, what is the car's final velocity? That's here, question mark. And what is the car's total displacement? Right here, question mark. Now, is there any information that tells us what the initial velocity was? There's no numbers in here, but we can actually infer this information because it says that the car is stopped at the red light. Now, if a car is stopped, we can infer that the velocity, or the initial velocity, was 0 meters per second. So we're done with our variables. So the next step is to select one of the equations that's going to help us answer the question. So let's focus on final velocity first. What we need is an equation that gives us almost all of the information except for that final velocity. So we cannot have two unknown variables. So I'm going to use my highlighter tool here to start highlighting the variables that we don't know. So in this first equation, we don't know displacement, and we know all the rest, but that's not going to help us find the final velocity. The second equation, we don't know displacement, and we don't know final velocity, so that's not going to help us. Third equation, we don't know final velocity, and we don't know displacement either. Last equation, we don't know final velocity, but we do know the rest. So bingo, we're going to use this one. In the next step, we're going to substitute our variables. So we have VF equals 5 times 7 plus 0. And that gives us a final velocity of 35 meters per second. Now to find the total displacement, we could really use any one of these except for the last one. So let's just pick the second equation. So we substitute again. We have delta x equals initial velocity is 0 plus final velocity is 35 over 2 times 7. If you get your calculator, 35 divided by 2 is 17.5 times 7, which is 122.5 meters. So in conclusion, in those 7 seconds after the light turned green, the car traveled 122.5 meters, and it was going 35 meters per second at the end of the 7th second.